Today, we're going to look at the law of sines and cosines. The law of sines is about opposites. The first thing you need to notice is how the triangle is labeled. Angles are labeled with capital letters, and notice the lowercase sides in each case are opposite their corresponding capital letter. In other words, angle A opposite is side little a, and for angle B, opposite it is side little b, and for angle C, opposite it is side little c. For both law of sines and cosines, this is how your triangles are labeled. Then when you look at the law of sines, it says that the sine of angle A over its opposite side, little a, is equal to the sine of angle B over its opposite side, little b, is equal to the sine of angle C over its opposite side, little c. The law of sines is about opposites. What you need are two pairs of opposites. Any one thing can be missing, and you can solve for it. The last thing that is important to note here is that this works in any triangle. It doesn't need to be a right triangle. When I work with sine, cosine, and tangent, I need right triangles. But the law of sines and the law of cosines work in any triangle. Again, file this. You have to know this. The law of sines is about opposites. If you have two pairs of opposites and you're missing any one of them, you can solve for it. Let's look at this first example. We're going to find a length in this case. Notice that I have an angle and its opposite side. I have an angle and I don't know a side. Let's call that x. Notice the pattern. I have an angle on opposite side, an angle on an opposite side. Two pairs of opposites, and as long as I have three of them, I can solve for any one of them. Let's set this up. The sine of 40 degrees over its opposite side, 17, equals the sine of 45 degrees over its opposite side, x. Let's solve for x. We'll cross multiply. We'll take x times the sine of 40. That's x times the sine of 40 equals, cross multiply, 17 times the sine of 45. Now we can divide both sides by the sine of 40 and get x by itself. Don't forget, when you enter this in the calculator or Desmos, you need to make sure you're in degrees, not radians, or you'll be getting the wrong answers. Notice that these cancel, and I get x equals, I'll put this in the calculator. We'll round that to the 10th. It looks like it's about 18.7. When you finish a question, make sure your answer seems reasonable. Being that 40 is opposite of 17 and 45 is a bigger angle, it is logical that the side opposite the bigger angle would be bigger. Not a lot bigger, but somewhat. So this seems like a reasonable answer. If you get something like 200, you should be suspicious. In this example, we're going to use the law of sines to find an angle. Remember, when you find an angle using trigonometry, you use the inverse function. But we first of all set it up with the normal old law of sines. The law of sines is about opposites. I have 75 degrees and an opposite side, 30. I have 26 and there's an angle opposite C. That means I can find C. C is what I'm going to find. Let's set this up. The sine of 75 degrees over its opposite side, 30, equals the sine of angle C, you don't know what that is, over its opposite side, 26. Now let's cross multiply. 30 times the sine of C equals 26 times the sine of 75. We'll divide both sides by 30. We need to get this by itself first. Divide by 30. That cancels, and I see, change colors here, that the sine of C is equal to 26 times the sine of 75 over 30. What we need to do is put this in the calculator, and we need to take the inverse sine of that because we're finding angle C. In other words, our answer is this. The inverse sine of 26 times sine 75 over 30 is equal to C. I'll show you a couple of ways to plug that into Desmos. One way is to use lots of parentheses. Notice that I use parentheses inside here to do 26 times the sine of 75 and then divide by 30, and then I had to put parentheses around that to do the inverse sine of that. And there's my answer. I can see that C is 56.8 degrees. That's angle C. The other way is to use a variable, some variable, whatever you want. I notice X did not work. Possibly Y wouldn't. Those are used for graphing. But I just used Z, and I stored this value that I need to work out in Z, and then I took the inverse sine of it. I'm finding an angle. I need to use the inverse sine, cosine, or tangent when I find an angle. And since we're using Loft Signs, it's the inverse sine. Notice you get the same exact answer. The key thing to remember about Loft Signs is it's about opposites. You need two pairs of opposites, an angle and a side, an angle and a side, and any one thing can be missing, and you can use the law of sines to cross multiply and solve. The law of cosines works in two cases. Before we talk about what it looks like mathematically, you need to know these two or you don't know when to use it. The two cases are, if you have two sides and the included angle, you need to remember that included means between. So here we go. I've got an included angle. It's between the two sides. If you have two sides and the included angle, you can find the opposite side. That would be X in this case. So it works. If you have two sides and the included angle, you can find the opposite side. The other case is if you have all three sides, you can find any angle. Again, this does not need to be a right triangle. It works in any triangle. The law of cosine says that a squared equals b squared plus c squared. That looks kind of familiar, doesn't it? That will help you remember it. Minus 2bc times the cosine of the angle opposite, which in this case is A. Now there are two more that you will always see if you Google these or look them up in a textbook, but they are the same exact pattern, and you really only need to know the one. What are the two others? You could have b squared equals a squared plus c squared minus 2ac cosine B. Notice that B squared and angle B are opposite each other, little b and capital B. And C squared equals A squared plus B squared minus 2AB cosine C. And little c is opposite angle C. Observe the pattern. A squared equals B squared plus C squared. Notice that these two numbers occur right here, minus 2BC, cosine of the angle opposite. Observe the same patterns below. B squared equals A squared plus C squared. Those are the three sides of the triangle. Minus, and again, notice how these two occur right here. Minus 2AC cosine B. And the same one for the last. C squared equals A squared plus B squared. Notice how A and B occur right here. And then cosine of the angle opposite. You only need to remember one of these, because our triangles aren't going to always have the sides and angles labeled the same way. But the pattern holds. Let's try an example. Very important. When can you use this? If you have two sides and the included angle, you can find the opposite side. That's our first example. And then if you have all three sides, you can find any angle. Let's give this a shot. So the law of cosine says that a squared equals b squared plus c squared minus 2bc cosine of angle A, where little a is opposite angle A. If we're going to find a side, we have to start with that side. Because notice how, look here, I'm going to find x. Opposite what we start with has to be the angle. And x is opposite the 70, so it'll be cosine 70. So start with the x. It'll be x squared equals, and then the other two sides, 18 squared plus 22 squared, minus 2 times 18 times 22 times the cosine of 70 degrees. Observe how x and 70 are opposite each other. Now we just need to simplify this. Now the nice thing is, this is the case where it's as simple as taking the square root of both sides. You could work this stuff out, but you don't need to. You can just plug it into Desmos as it is, and it will spit out the answer. So you'll start off with the square root in Desmos, and then 18 squared plus 22 squared minus 2 times 18 times 22 cosine of 70. Make sure you're in degrees. So I'll show you how to plug that in Desmos. Here's what it should look like. When you start typing, just type SQRT and the square root will pop up. And just type that whole statement under the square root. Make sure you're in degrees, not radians. Most of these questions will probably ask you to round to the 10th. So this would be about 23.2. Make sure your answer is reasonable. Take a look at the triangle. Does 23.2 seem like a reasonable answer? Looking at the triangle, it looks good to me. Here is one more example of law of cosines, which is a squared equals b squared plus c squared minus 2bc cosine of a, where little a, the side, is opposite angle A. I'm going to pick one angle randomly, and I just need to remember that the side I start with and the angle I end with need to be opposite each other. So if I'm going to find x, that means I have to start with the 20. 20 squared equals, now it's the other two sides, b squared and c squared are the other two sides. That's 15 squared plus 18 squared minus 2 times 15 times 18 times the cosine. And what's important is that the 20 and the angle are opposite each other, and we didn't know what it was. Cosine of A, I could call that A if you want, or you can put an X there, whatever, I'll call it A. In this case, we actually have to work some of these pieces out. 20 times 20 is 400. 15 times 15 is 225. 18 squared is 324. Minus 2 times 15 is 30. And 30 times 18 is 540. Cosine of A. Let's combine this. Now, keep in mind, I can't separate these two because there's times between them. I'm going to have to divide to get rid of that 540. But let's combine these two. 225 plus 324 is 549. So 400 equals 549 minus 540 cosine of A. To get rid of the 540, because there's times, I have to divide. So first of all, I'm going to solve for A. I need A by itself. I'm going to move this over there, and I'll subtract 549 from each side. 400 minus 549 is negative, don't worry, negative 149 equals, and I'll bring that down, negative 540 cosine of A. Now I can finally divide and get rid of that negative 540. Divide both sides by negative 540. And I see that the cosine of A, I'm going to flip this around. Notice the two negatives here. Two negatives when you divide make a positive. Is 149 divided by 540. Now I need to find the angle that's its cosine is 149 divided by 540. I'm finding an angle. That means I need to use the inverse function. This means that I'm looking for the inverse cosine of my ratio, 149 divided by 540, and that's going to be equal to the angle A, whatever A is. And I guess we should say the measure of angle A. In Desmos, I put the inverse cosine of 149 divided by 540. This is an angle, and we'll round it to the 10th. 73.98. I look at the 8 to round, and that bumps the 9 to a 10. I have to carry the 1. It looks like that the measure of angle A then is 74 degrees. If this all seems a little fuzzy to you, my suggestion is to look at the examples I work out. The rest of the video is examples from your assignment. There are 10 questions with law of sines and 10 with law of cosines. Please get going on this right away. At least do the first 10 questions today or tomorrow, and then get going on the law of cosines. So take a look at some of the examples in the video, and they should help you with your homework. Here are questions from your assignment. The thing you need to remember is that law of sines is about opposites. I need two pairs of opposites. Any one thing can be missing. Law of cosines works in two cases. If I have the included angle, I can find that opposite side, or if I have all three sides, I can find any angle. You've got to get that down, or you're not going to know what to do when you run to the situation. Question 1. Given that AB is 125, that angle B is 62 degrees, angle C is 52 degrees, find AC. Let's call that little b because it's opposite B. Remember those three situations. Law of sines, about opposites. Law of cosines, if you have the included angle, you can find the opposite side. If you have all three sides, you can find any angle. What we have here is two pairs of opposites. We have 52 and 125, and we have 62 in the B we're looking for. That's segment AC. Two pairs of opposites is law of sines. Set up your law of sines. The sine of 52 over its opposite side, 125, equals the sine of 62 over its opposite side, B. Let's cross multiply. B times the sine of 52 equals 125 times the sine of 62. I've got times here. I need to get B by itself. So I'll divide both sides by the sine of 52 and cancel. And I'll put this in the calculator, making sure that it is in degrees, not radians. The length we are looking for then is to the nearest tenth, 140.1. Question 2. We've got AB is 155, that the measure of B is 57 degrees, and the measure of C is 86. Find AC. Since that's opposite B, I'm going to call it little b. And it looks like we have two pairs of opposites again. We have 155 and 86. Those are opposites. And we have 57 in the side we're looking for, which I called B. Set up your law of sines. The sine of 86 over its opposite side, 155, equals the sine of 57 over its opposite side, B. And we'll cross multiply. B times the sine of 86 equals 155 times the sine of 57. We're going to get B by itself because there's multiplication. We'll divide. Divide both sides by the sine of 86. Those cancel. And we get B equals, put that in the calculator. And to the nearest tenth, we get 130.3. In question 4, we're looking for angle C. And we have its opposite side, 85. And we have an angle in its opposite side. Again, we're dealing with two pairs of opposites. That's law of sines. Key thing to remember here is we're looking for an angle. And when you're looking for an angle, you use the inverse function. Don't worry about that until you're at the last step. So set it up just like normal. We can say that the sine of angle C, what we're looking for, over 85, its opposite side, is this equal to the sine of 86 over its opposite side, 150. And we'll cross multiply. 150 times the sine of angle C equals 85 times the sine of 86. Now to find C, we need to get this by itself. So we'll divide both sides by 150. And this cancels, and we know that the sine of C is equal to this. So what we do is, to figure this out, we need to do the inverse sine, because we're looking for an angle. It'll be the inverse sine of the ratio, which is 85 times the sine of 86 divided by 150. And that will be equal to the angle we're looking for, the measure of angle C. We can put this in the calculator a couple different ways. I'll show you both. So I just plugged in exactly as it was, and I found that the measure of C So the nearest tenth is 34.4 degrees. Or you could just plug in the fraction and store it in a variable and then do the inverse sign on the next line, which would look like this. See how I plugged in the fraction? I picked a variable. You can pick any variable you want. I noticed that x seems to give it an error, so I guess don't pick x or y. Use any variable you want there, and then do the inverse sign of that variable in the next line. To store a variable in Desmos, you just type the variable equals whatever it is, and on the next line, that's what the variable will be. We get that same answer of 34.4 degrees. Question 5 is our last example of loft signs. Notice how we're looking for angle B, and we have its opposite side, and we're giving another angle in its opposite side. All about opposites. You need two pairs of opposites. Any one thing can be missing. We're looking for an angle. At some point, we're going to use the inverse sign, but set it up like normal. The sine of angle B over its opposite side, 120, is equal to the sine of angle C, which is 59 degrees, over its opposite, 120. Oh, that's interesting. This is an isosceles triangle. Which means this angle ought to be 59 degrees. Well, let's check. We'll cross multiply. 120 times the sine of B equals 120 times the sine of 59. And we'll get the sine of B by itself, so we can take the inverse sign. We'll divide by 120. This is what we put into our calculator. But remember, we're finding the inverse sign to get the angle. It'll be the inverse sign of that ratio, 120 times the sine of 59 divided by 120. Interesting, these two actually cancel. So this would be the measure of angle B that we're looking for, that we suspect is 59 because it's isosceles. And we see the measure of angle B equals, we'll plug that in Desmos. And look at that. It came out to be 59 degrees, exactly like we thought it would. The law of sines is about opposites. Two pairs of opposites, any one thing could be missing. You can solve for it. The law of cosines has two different cases. You can have the included angle. That's when an angle's between the two sides. Notice that's what we have here. It's included. It's between the two sides. What that means in that case is we can find the opposite side. We'll call that little b again. Two cases. So one of them is the included angle. You can find the opposite side. And the second case is if you have all three sides, you can find any angle. So this is the first case. The way it works is that our side and our angle, side we begin with and the angle we end with, have to be opposite each other. Since we're looking for the side of length B, we're going to end with the cosine of 58. We'll start with B squared. We're going to end with the cosine of 58. So b squared equals the other two sides squared, 140 squared plus 150 squared minus 2 times 140 times 150 cosine of 58. Now since we're just finding b, we can just take the square root of both sides and not work anything out. We can just plug this in the calculator exactly like that, and we'll immediately know what b is. Just takes a little time to plug it in the calculator. To the nearest tenth, it looks like b is 140.9. Question 12. Notice that we have an included angle. is between the two sides. That's the case where we can find the opposite side, which I'll call C here, little c. We start with the side that is we're solving for that's going to be opposite the angle. In other words, it's going to be c squared and cosine of c. And then these are the other two sides, 130 squared plus 110 squared minus 2, and repeat those, 130 times 110 cosine of c. And because we're just plugging this in the calculator, square root of this will give us what c is. Put that in the calculator, you got it. Plugging that in Desmos gives me to the nearest tenth that c has a length of 150.2. Always check that your answer is reasonable. Look at the other two sides, 130 and 110. So this must be the biggest side, 150.2. Question 14 is the second case of the law of cosines. If you have all three sides, you can find any angle. We are looking for an angle, so at some point we're going to use the inverse cosine, but again, set it up like normal. And the rule is that the side you start with and the angle you end with, which is the one we're going to want to find, need to be the opposite of each other. So we're looking for angle A, and we're going to start with 160. 160 squared equals 165 squared plus 40 squared minus 2, and repeat those numbers, 165 times 40, and then cosine of the angle we're looking for, which in this case is A. In this type of law of cosines, we've got to work the pieces out. We don't have any choice. So plug this in the calculator. Keep in mind, all this stuff is multiplied by the cosine of A. So I'm going to have to divide to get rid of that. But I can add 165 squared plus 40 squared, and then subtract it and move it over there. 160 squared is 25,600. 165 squared plus 40 squared is 28,825. 2 times 165 times 40 is 13,200 times the cosine of A. Now, we'll subtract this from both sides. Here we're going to get negative 3,225 equals negative 13,200 cosine of A. And we need to get the cosine of A by itself, so we can do the inverse cosine. Divide both sides by negative 13,200. Now we need to work out the inverse cosine. And notice here that two negatives make a positive. So the inverse cosine of 3,225 divided by 13,200, and that will get us the measure of angle A. So put that in the calculator, and we get to the nearest tenth, 75.9 degrees. Last example here. This is the case where we have all three sides. We can find any angle we need. This time we're going to find the angle of B. Remember that we start with the two that are opposite each other. We are going to end with the cosine of B, And we're going to start with 125 squared, the side opposite. And that will equal the other two sides squared, summed together, minus 2 times 120 times 70. These two repeat right here and here. Cosine of the angle we're looking for. We're looking for an angle. We're going to end up using the inverse cosine at some point. We first need to work some of this out. 125 squared is 15,625. 120 squared plus 70 squared is 19,300. 2 times 120 times 70 is 16,800 cosine of B. Now we're going to get this by itself. Remember that we have to divide to get rid of the 16,800. First, move this to the other side. Subtract 19,300 from 15,625. We get negative 3,675 equals negative 16,800 times the cosine of B. Now we can solve for the cosine of B. We'll divide by 16,800, negative. Notice here that when you divide, two negatives make a positive. So to find our answer, we're going to need to do the inverse cosine of that ratio, 3,675 divided by 16,800, and that will get us the measure of angle B. So plug that in the calculator. According to Desmos, the measure of angle B to the nearest tenth is 77.4 degrees. Again, glance at your question and make sure that seems reasonable. Once you've learned how to use the law of sines and cosines, that's one part of it. You have to know when you can use it. Law of sines is about two pairs of opposites, an angle and a side, and you can be missing any one of them and find it. Law of cosines works in two cases. If you have the included angle, you can find the opposite side. If you have all three sides, you can find any angle.